Hello everyone, my name is Jamie from UC Berkeley's PEACE Tutoring organization, and this time I will go over what sequences are, the general concept of arithmetic sequences, and 2 practice problems. First, let's go over what a sequence is. A sequence is just an ordered list of numbers with an associated pattern to it. So this is not a list where all of the items are random, but each item or each element has its place in the sequence. And the big idea here is that each element in the list can be computed mathematically. You should be able to express every numeric element in the list with a formula. Now let's talk a little bit about the sequence elements themselves. As I mentioned, the sequence is an ordered list of elements. So the first element in the list, or sequence here, is the number 3. And since it's the first element in the list, we call it A1. Subsequently, the second element in the list is 11, and it's denoted A2 after the second element in the list, and so on. Sequences can be finite or infinite. As shown here, the first finite sequence starts at 2 and ends with the fifth element, 10, while the sequence below it goes on forever. So it should be pretty easy to tell which one you're dealing with. If someone asked you to count or list all the aisle seats on an airplane, that would have an ending. So it would be a finite sequence. But if someone asked you to count all of the odd numbers, that would go on forever. With finite sequences, we can easily do calculations, like what's the sum of the entire list, or find the 800th element in the list. With infinite sequences, when you take a sum, now we have to go into limits. Here, if we keep adding more and more elements to the list, the sum just keeps getting bigger and bigger, but not all sequences diverge. Some converge onto a single number, which is pretty nice, but that's not what we're going to go over in this video. There are a couple of types of different sequences. The most common are arithmetic, geometric, and recursive sequences, and in this video, we will only focus on arithmetic sequences. Arithmetic sequences contain consecutive terms with a constant difference. Here you can clearly see that each element in the list is increased by 2, which is just adding 2 to the previous element in the sequence. While the bottom sequence here has its first element starting at 10, and then the next element in the sequence decreases by 2. Again, the pattern here is just a constant difference, nothing special. All right, so let's take a look at a case example. We have a sequence that goes on forever, so right off the bat, we'll know it's an infinite sequence. The first element here starts at 3, and you can easily spot the common difference here, which is 8. Each element in the list increases by 8. Simple enough, the first element is 3, the fifth element is 35, but what if I asked you to compute the 781st element? It would be pretty annoying to punch plus 8 into a calculator 780 times. The powerful thing here is that we can just come up with a formula right off the bat, so questions like that become really easy. We know the first element in the list and the common difference, and that's all you need to know to find the nth element in the list. If you think about it, to find the 781st element in the list, you add 8 to the first element 780 times, or n minus 1 times. So the 781st element is the starting element 3 plus 780 times the difference 8. Generally, to find any number element in an arithmetic sequence, you just need to know the starting element, the distance, and the number item you're looking for. Great. So now that we've gone over the concept of sequences, specifically arithmetic sequences, we can go right into 2 of the most common practice problems. The first covers a question that gives you the first 5 elements in a sequence and then asks you to find the 36th term minus the 12th term. Sounds easy enough. We just learned how to find the nth element in an arithmetic list. All you need is the starting element in the sequence and its spacing between any 2 elements. So our first term here is 7. So now all we need is the spacing or difference between 2 consecutive elements. You can easily confirm here that the distance between the elements here is plus 16. So then our formula here is our starting element 7 plus the distance 16 times the number of elements minus 1, or n minus 1. So our 12th element in the list is going to be 7 plus 16 times 12 minus 1, which is 183. And then our 36th element is 7 plus 16 times 36 minus 1, or 567. Now that you know A36 and A12, to find the difference between those two numbers, you can just subtract the two to get 384. All right, that was the first practice problem. The second question gives you two element items in the list or sequence, and then asks you to find a third one. Go ahead and pause the video and try to see if you can answer this one on your own. Okay, so we only know one formula here, and that's an equals a1 plus the distance times n minus 1. The problem right now is that we don't know what the distance is, nor do we know what a1 is. But that's okay, we can solve for both given the information that we already have. We can plug into our first value, a5, which is equal to 22, equals a1 plus d times 5 minus 1. And we also know that a15 is equal to 62, equals a1 plus d times 15 minus 1. So now that we have two equations and two unknowns, that means we can solve the equations. First, let's subtract the two equations and get rid of a1, giving us 40 equals 10d, solve for d equals 4. Now that we know the distance, we can just plug it back into either of the equations and solve for a1. So I just plugged it right into the first equation to get 22 equals a1 plus the distance, which is 4, times 5 minus 1 to get the first element in the sequence is 6. Now that we know the distance and the first element in the sequence, we can just plug it right back into our formula to find the 140th element in the sequence, and we find that the number is 562. Great! Now you know the basics of arithmetic sequences. Hope that was easy to pick up. A little bit more of an interesting problem is to find the sum of a finite sequence. For example, what is the sum of all of the even elements in a list or sequence from 200 to 250? Go ahead and try the problem out, see if you can come up with the answer, and we'll discuss it in the next video.